Good morning, everybody. Let's see who's on. Good morning, Walleye King. Good morning, Susan. Good morning, Tim. Good morning, Wally B. Good morning, Mysterioso Paul Collins. Good morning, Rocket Bob. Good morning, Quake Cat Ute. Good morning, Canuck. Good morning, Margie. Is cool, which she is. She's cool. In this hot weather. Let's see, Comanche. Good morning, Comanche. Good morning, Flutterby. Good morning, Double Scoops. Good morning, Doc Rock. And see, you got Doc Rock and you got Rocket Bob. Mm-hmm. Good morning, Denise in the UK. Brainstorm Warming and Longamar. And I suppose my boy Snarls is, having to deal with somebody who's shouldn't have to deal with, but he does because where he works. Yeah. Good morning to all of y'all. It's July 26th. And there's been zero neutrino discovered on Earth. Huh? Yeah, okay, buddy. Uh, Interesting video there by that girl. I like her. She explains things in a way that's a little bit easier to understand than most of the brainiacs do, in my opinion. So I enjoyed her thought processes. She's much like uh, Miss Scove, who explains solar weather. I think together they actually give us a pretty good understanding of what's going on beyond our Earth and how that which is going on beyond our Earth affects our Earth. I think I'm waiting for maybe another piece or two. And then from this information, we can then extrapolate ideas and try some new ideas um, with understanding how and what and when our Earth responds to what's going on beyond our planet, and to see just how much or and how little that what's going beyond our planet really does affect our daily life. And that's kind of the direction that I'm going after. Uh, Mankind's playing around and stuff with CERN and all that, and the weather creation and lack thereof. Um, uh, it's all part of the equation, and uh, my goal has always been not to forecast earthquakes, or even tell you when an earthquake is going to happen, but more why an earthquake is happening. Um, and you say, "Oh, it's just plate tectonics." Well, you're full of shit if you think that it's just plate tectonics. Oh, it's just random. Yeah, you're dumber than I thought you were. Just being random or just being plate tectonics. Uh, no, and just my opinion, and it's a strong opinion I have of myself there. And just I just don't think it happens that way. Yeah, the waves of magnetism from the core. Yeah, that's interesting too, and how electromagnetic waves happen, and these special waves that are coming from outside of our planet, coming to our planet, uh, from our Earth. I mean, from our sun and from other entities. I think it's really interesting. It's intriguing, um, because I think they add to the story. So, observing how things work on Earth, and I think is critical. That's why we study geology and geography and all the other sciences. Um, some rock science and um, some astrophysics, astrophysics as well. Hey, you've got to be a jack of all trades to synthesize some of this to get a larger picture. And that's probably my personal goal, is just get a little piece of information and understand how the generalized thing works, and then go to the next thing, and then see how they interact or don't, for that matter. And it's a growing process, and it's all about learning. Um, Everybody here is not waiting for me to forecast the next 8 that we're gonna get, uh, because that's not what we do here. We engage quite a bit in a lot of theoretical talk, hypothetical talk, and also some stuff that is pretty well established science, and that's kind of our thing here. That's why I enjoy uh, Wally's musing in his mind, and what how he's seeing the planet and the way things work. Also on Walleye King, um, so Walleye K and Walleye B. You I don't know why I'm coughing so much, but I enjoy all these discussions we have, and there's many, like Kat. She's got a lot of interesting, um, anecdotes she puts up there, and the strength of Canuck and his historical memories of reading articles and applying them to the historical record, recent historical record of earthquakes and where they've happened, and trying to triangulate events and to see the larger picture rather than just, oh yeah, there was an earthquake here in 1951 and it did this. No, he kind of looks at things and says, look, this is what led up to it, by saying, look, this happened here, this happened there, that happened here, and because of that happening in 1951 there, let's see if there's a persistent pattern that when that place has an earthquake, we can go back and look at the historical record and see if that's the pattern it happens. And pretty much it does happen like that. That there will be plate movement, there will be solar activity, be weather activity, there will be liniment activity, and bringing that together, you look at solar activity for that matter, and outside solar activity, and where we were located in the universe. So bringing all these little things together, I'm sure it's not in totality of everything that I've said. There's a lot more to be added, but that's what we're doing. We're bringing all these different facets of science and study together to bring a more clear picture of, yeah, an earthquake happened today in San Francisco. It's kind of like, okay, do we just look at the damage it created? No, but I mean, why was there an earthquake there? And will it happen again? And if so, will it be greater or lesser than it happened then? And that's kind of what our channel is really all about. And for some people, they don't really care about the science outside of our planet, but I do, and I think that's part of it. I think by looking at different aspects or different disciplines, we can learn a lot more. Mechanics, we can learn a lot from mechanics. You know, um, and there's things that are going to be beyond us, and that's why, in a corporate sense, we can grab more information. And so the morning report, again, is more about, okay, this is what's happening right now. I'm not going into great detail because there's so many people here that are super smart and have their ideas, and they can see from the morning report what's going on and divulge for themselves where to be watching and where to be looking, and trying to see why it's happening, not just that it did happen. You know, you get a bruise on your arm. Why? Because you banged a damn thing. Okay. Well, it's not so much the bruise on the arm, it's that you banged it. And how did you bang it? And you know what I'm saying? So it's earthquake. That's kind of like the last thing that happens. Well, the damage happens, right? And that propagates through wavelengths all the way out to other areas where they have earthquakes, stress accumulation, Coulomb stress, and all that. But earthquakes themselves aren't the end, or they're not the beginning. They're not the end either. So by looking at these other disciplines, that's why we touch on solar stuff. That's why we touch on extrasolar stuff. That's why we get into physics, and which I'll be doing a lot more of. And we'll have really cool discussions about bending time and light and all that. And I thought that the young ladies' discussions in this last video we watched were really, really cool, because she mentioned something I thought was interesting, how they slowed light down. Yeah, I thought that was cool. But anyway, that's just me, you know, my little pet peeve. So let's start it off. Solar wind right now is 521 kilometers a second. Density, the proton density, is at about 8. We've had an M4 here in the last 6 hours. Can you believe that? Yeah. So we've had one. And let me show you where it was. Here we go. Let's go ahead and watch it. There's a zap right over Saudi Arabia. Last night we had one over Southern California, just off our coast. There's one. Wow, that's a good one. Boom, right over Central Africa. Yep, that was pretty intense too. And you can see the green coming up, so you know that radiation, or irradiation, IR, is continuing to charge our planet. We call it charging, but we might be saying it wrong, but we're saying it that way. Boom, there's another one. Yep, over the Atlantic. Oh, right. Oh my God. I guess it just happened right over Puerto Rico. Boom, right there. That'd be about an M1, right? Yeah, right over Puerto Rico. The other one was right over Africa, and that's an M4. Yeah. So we have at least 2 of them now, and this one just occurred at looks like 1600 UT. So we'll take a look at that here. A mystery of CME sparks geometric storm. Yeah. Yeah, G1 class. Yes, last night we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sunspots. 4 are leaving us, or 3 are leaving us sooner than the 4th. And yeah, pretty far out, eh? 76 and 80 pose a threat. 76 up here and 80 right here pose a threat for M flares. Yep. So If we looked at LASCO, let's look at the short LASCO 2. See if anything's popped out. It's 25 here today. It's 26 today. Doesn't look like anything popped out at us today. Up to the time frame that they have. Here's the large vision. Let's go 3. There's the 23rd, 20. Here we are on the 26th. Not seeing a CME shot out at us, so that's good news. We can look at stereo here real quick just to verify this. I don't know how close it'll get to the real time here on stereo, but sorry about the hum. We definitely need to get some airflow through here. All right. Okay, that was on the 20 something here. There's the 25th popping out. That one will hit us in about 3 days, if it hits us at all. We'll look that up in just a minute. You're on the 25th, 26th now. 9, 10, 11, 12. Nope, doesn't look like anything. We'll watch it one more time through. Right at the end is what I was trying to look at. Here's the 25th, 26, 7, 8, 9, 10. All right. 1300, 1500. Nope, doesn't look like anything happened. All right, so no more CMEs, so we can, yeah, that's the latest one, and that happens at 1600. Let's go ahead and look at it. X-rays here. Yeah, you can see we just had it right there. And then this is the M4. We had an M1 earlier, and this is the one. Yeah, this is the one that pissed me off last night. and then another one happened. Yeah, we just had this M1 here at 1600, and the other one, M4, happened at 6 hours before that, 5.5 hours before that, and then the one prior 6 hours before. So that happened about midnight my time, I guess. And then this is the one that messed my phone up, and I was so damn angry yesterday. One, Verizon is good, but I'll tell you, Verizon uses satellite or something. I don't know what they're doing. Microwaves, they get screwed up, and I want to throw my phone through the damn wall. Why? Because I want to talk to somebody. Shit. All right, so we did just have an M1, and they don't have it on the list here yet. M4 is the largest, so they haven't updated. Welcome back, Steve. During last night's geomagnetic storm, Jody Bragg Creek, Alberta, went outside to look at the auroras. Instead, there was a Steve. That's the trail of a mosquito. Yeah, that's what we call Steves, mosquitoes. Steve has decided to make an appearance of a couple hours shortly after the midnight, says Madco. A beam of the northern horizon almost to the southern horizon, a brightest I've ever seen it, she says. Steve is a strong thermal emission velocity enhancement. Looks like an aurora, but it's not. It's a phenomenon caused by 3,000 degrees Celsius ribbons of gas flowing through Earth's magnetosphere at speeds exceeding 6 kilometers a second or 13,000 miles an hour. This ribbon appears during some geomagnetic storms, revealing themselves by their soft purple glow. Yeah, they're laser beams from a satellite. Is, a little conspiracy here. No, I'm just kidding. Right? Or am I? Anyway, we've seen those quite a bit, especially when they cause fires. It seems like they go right where the fires are, right? Oh, that's right. Remember when they changed COD? Yeah, we couldn't see it no more. Yeah, they just did some. Okay, let's get rid of this, where they can't see our laser beams anymore. Yeah, the greater the detail, greater things that we learn, and they get scared. What was I looking up here? Oh yeah, this one here. All right, this is from 7 to up to 731. This is from the North Pole looking toward the south, and this is the side view. This is the radial wind, and this is the plasma density. See if they have anything coming at us. Doesn't look like it. Yeah, NOAA doesn't have anything popping at us. That's good. This one's a little bit harder. This is from NASA, I believe. Yeah, radiation plasma effects, right? No, events. We'll open this up. There was one that shot off north of us. I didn't think it was going to get us. This one goes all the way to 8.4. So yeah, right now we're pretty clear. So they have it, us clear. So all right. Let's see. All this interest about this thing looking like the Millennium Falcon or having horns. This asteroid, all of a sudden, something popped and made it look like horns. Right now, KP index is unsettled, it says. So, yep. And the noctilucent clouds, are still happening. Happening on the top of the Earth. Let's see. 25th. Today's the 26th. All right, so right here. 35% chance for an M, which we've already had one this morning, just an hour ago. And a Class X is 5% chance. Geometric storm, 35% chance for mid latitudes, 15 are for upper. There's a 36 fireballs rushing because of all of the meteors are zipping through the atmosphere. So that number's up. There's still 2,335 FAWs, or potentially hazardous asteroids they're watching, that are in and around the 5% of the distance from the Earth toward the sun. And those things that are a football field size or larger is a potentially hazardous object. But they do show smaller ones. Today being the 26th, there is no rock right now. Tomorrow there will be one that is, 46 feet across. No, 44 feet across. And thereabouts. I don't know what 318 is. I think that's at 44, right? 18 times 3. 54, sorry. 54 feet across. And it'll be 3 lunar distances away. We use lunar distances because that's really the only measuring stick that we have out there to say, well, is it in that 5% distance from the Earth toward the sun? Mars is too far away. And so what do we use? So we use the moon distance from Earth to the moon, which is about 384,400 kilometers. And also it's 0.00256 AUs, right? That's 1 LD. And so we all look at that. Nothing's real close to us here in the next month or so, all the way through September. Tomorrow is the closest object, come 3.1 lunar distances away. So nothing to be worrying about now unless they discover something brand new, which they do all the time. So we're not going to worry about that. Find Uranus. Have you found Uranus today? Is it a glass cloud or is it a gaseous cloud? Glass. Yeah. There you have it. Uranus is just the other side of Jupiter. Saturn, they're all watching, right? Venus, Mercury. You heard them talk about Venus and Mercury being lined up where you can almost see them together in the morning. Saturn and Neptune, I guess they're lit up. And Jupiter and Uranus is behind Jupiter. So two big gassers. Mm-hmm. Yeah, I bet you didn't know Saturn was considered a gas giant. These are 4 gas giants, right? I don't know. Does a gas giant mean it has solid? Isn't that a fart you can't trust? Yeah. Yeah, you know when you get older, not to trust them farts. No. Nope. He might have an accident. Yeah, you never heard that joke, huh? Yeah. Well, I can't say it because it's pretty nasty. But I just gave part of it. Let's see. Let's look at the tremors. Do we have any tremors in the Pacific Northwest? We talk about them quite a bit because that's the only measuring place we've got that measures the tremors, because there's the subduction zone offshore. And there's a bunch of volcanoes there, and, you know, St. Helens being one of them. You can see quite a bit. 225, but creaking, cracking little tremors. A lot of it down by Medford and Oregon border, California border, and a lot up and right up there in the Olympic. Part of the Olympic Walla Walla liniment. Yep. And yeah. So crazy. Do we have any drunk Chinamen out there? Yeah. Now let me see. The drunk Chinamen being, if you haven't heard, I think we picked up on a code that the Chinese submarines were doing when they had them out here. They'd come by and bang one of these satellites or these stations out here and let their home people know where they're at, because they would come back here, come back down here, come back. And then ever since the United States started traveling through the Formosa Strait, because we're allowed to, international waters and all, it stopped. So I think they found out what we were doing, and they since changed their deal. The Russians were doing it too. We'd see them off the coast here periodically. And we seen one that was banging out here, the Thompson Seamount. And it wasn't the only seamount that had been bouncing. This one up here too. Now it's offline. So we watch these things. Of course, this is all just joking, right? We watch all these buoys to see, hey, if there's some activity happening. Generally, tsunamis will happen. We have the tsunami page here. No tsunami warnings at all. Not even from the 6.8 Vanuatu that happened today. So, so no tsunami. We were looking for something very strong to come through that way because of the deep quakes that happened in Fiji. Right? Do you remember those? The series of quakes that happened in Fiji, like 5 or 6, that were so deep, very strong. So this is a 6.4 that USGS has it as. And you can see the tensor ball saying, what kind of, let me go like this, and say what kind of strike is that? Is that a I mean, what kind of quake was it? You know, was it a strike slip or a dip slip? Or here we go. We'll take a look at this. So what's it symbolize? Probably a reverse a little bit, right? You know, there's a low angle reverse. You just kind of rotate on that side. It's a low angle reverse. Pretty close to that. So what does that mean? Well, if the pressure was out here and moved that direction, reverse P, this would be P, where one rides over the top of the other, right? So the P riding over the top of the T is what happened. Okay. So the P riding over the top of the T right there. So there's the area here, but let's see. Is that a subduction zone? I don't think so. I think it's a, well, I guess it is. Oops, sorry. So here's the this one's eating up this one, right? So the P going over the T. I think you can see what I'm saying here. The P going over the T. The P going over the T. Well, interesting. We had all those big freaking bombing ones, super deep. There was 500 of them in there. I mean, 500 depth, and they were all fives, probably 6 or 8 of them. We'll find out how many in just a minute. Let's look at the origin. The origins page, magnitudes, body. So they look like to be a 6.7. Yeah, 6.7, 6.7, 6.7, 6.5, 6.7, 6.6, 6.7, almost 6.8, 6.8, 6.5, 5, 6.8, 6.9, 6.7. Yeah, so that was a pretty good little rocker. You know, no doubt. They got it at 6.4, probably because it didn't create any damage. And so the factoring of, you know, the way they do it nowadays. I don't know how many of you have seen the video where this young lady, she explains how they now look at magnitudes of earthquakes. It's not in the old way as we did before. I'm trying to find it for you. It was at well, well, I can't find it. I'll find it for you. I need to put that on a thing where I can access it quickly. Yeah, I don't know where the hell I put it. Shoot, I saw it again yesterday, and I wanted to you know, get it to you again so you can understand how they see it, how the USGS calls out these quakes. Yeah, we call it 5.1, right, or a 6.4. It's not the same way. They have a lot of other factors now that they bring into play. And boy, it was on my Twitter, and It was a long time ago, and the gal, she's pretty good at what she brings to our attention and how they say what they say in regarding to the size of earthquakes. We really have to look at it differently because it means a whole lot different than how we think about it in the past. Hold on a second. I apologize. I just had a cough real strong there. Yeah, is this? I don't know. I don't even remember who she was, but um, it was a long time ago. And anyway, she says part of it is damage. I think that a quake created, and that's why they don't look at the magnitude anymore. So I mean, the magnitude being okay, that's a 5. Wow. Now they look at a lot of other factors and how they determine what they are. So they've been going back and forth in time and reevaluating, like the earthquakes that happened in San Francisco or the Owens Valley earthquake that happened in the 1800s. So that's why the changing of the size or magnitudes are happening because we're trying to I mean they are trying to have a different way of looking at it and to make it uniform with all the earthquakes, and I think that's their goal, is to make it uniform. And man, shoot, I'm all the way back to what, May? Yeah, shoot, I think it was before May. The retweeting of these things. But we should be aware of all those things, and I'll find it for you eventually. I just don't remember who it was that said it, and and how it was said, because there's a couple of factors, and I would hope that I would be able to convey that to you a little bit better as I'm speedily going through my history over on Twitter, and because I don't know where to find the damn thing. I kept it somewhere, and I tried to put it in a place where I can easily access it. But I just can't. I apologize. I thought I had the damn thing too. Yeah, it should be under like a Twitter link, and it's not. Crap. Well, I'm sorry. Can't find it. I don't know. Did you guys find it? Wally, but if 8 happens in the ocean and not one there to see it, should we keep it a secret? God bless living amongst liars. Um, Give us a magnitude of the level of damage. Quake. The quake does not care who or what it shakes up. Right? Yeah. Their formation or their ideas just maybe it got slipped into this one. Yeah, I can't find a damn thing. That sucks. I thought I was going to talk about it today again because I found it and then I put it somewhere and I forgot where I put it. Ain't that about a bitch? Oh my god. I have too many links here, and I know it was on Twitter that I saw it, so I know what to look for now. I just don't know where the hell I put it. Did I put it in tools? Maybe I did. We get so many different tools. There's about 500 tools I have for sure. And then you start looking at those, like, what? What do you mean? Oh, why did I need that? Crap. You know, this gal, I think she's part of the USGS or somebody, or affiliated with them, or she's, watches them. I don't know what Clayton Hatchard is right here. No. Definitely not this one. Milkman Doom. Yep. He says, yep, I agree with you there. Yeah. Hunter Biden's plea deal is derailed. Right. Anyway, so what? Anyway, so obviously it was a heavier quake, but they lowered it to 6.4 because they have their reasons. And you can see clearly a 5.0, a 5.0, and a 5.2. When we saw on the right side of the dummy bell, right, of the doohickey here, man, right? You know what the doohickey is, right? Pressure's on this side, tension's on that side. So this side went above that side. This side is where the pressure came from, but these quakes happened after, right? Yeah. After it. So when this gave way, these moved more. So out this way, where these guys happened, bang, right? This just came in right now. This is a 5.1 on Mumri, Indonesia. See, do we have a tension ball for that one? No. The EMSC also has some tools. Like if we just look at the latest one, Oklahoma just had a 2, right? Florida SC 5.1. We look at the maps. Moment tensors. This one doesn't have a moment tensor yet. Regional moment tensors, so we can look at the historical record and look at this particular one. Man, it's super slow too. So this happened right down in here, and you can see, these type of strike slips, right? And if we took a look at this in the region, almost like this, a strike slip, right? Some of them may have, oblique, like this one here. But right in this area is pretty much dead on strike slips. So we can surmise kind of what happened on that particular quake. Now let's go ahead and look at the 6.4. Man, come on. The Vanuatu, right? Maps. Here's the moment tensor, right? There's the moment tensor, right? And this is the area, right? Moment tensor, that's what they're looking at. Let's look at the maps, and we go regional moment tensors. So pretty much you can see how they work. The yellow ones here, right? On this plane. It wasn't too long ago that there was one that happened right in the bay. We had a 7 right in here, right? And you can see they have a, what the hell is it? Why do they have this thing here? So probably need to open up this. Oh no, this one. Sorry. To look at it. There they have this one, but the USGS does not. That's a purple, so that's compressional. The red is the rift. The purple is compressional. The blue is subduction, and the green is strike slip. Strike slips come out of the rifts. The rifts on a rift. There's a rift here, right? So what will happen is part of it will break. Part will break, and the rift will be here. So what will happen is that's why you start to see these things. And where they break, those are strike slips. So what will happen again is that it'll rift again. And again, I'll have to erase this. And that's how these things get going. It just all depends on the weakness of the land that's out here. It's just weaker here. It gives way more here. Now this could have been way at the other side where it gave in more. All this is all relative. So that's how these things are starting, from my understanding. That's why I'm looking at them. So if the pressure overtops the tension, there's the line here, but the other one that went through here is what we're looking at in the tectonic map. That compressional is what looks like it popped. So one got shot up over the other. So I would think that this side popped up over this side. So just like it was flat like this, or maybe a round, and it just popped up and over it. Why it didn't create a tsunami is probably because of its depth, right? 10 kilometers, wow. Why it didn't do a tsunami, I don't know. Maybe did a local tsunami. Yeah. Yeah. Is this uplifting? See these upliftings? So that's how these things are made. Pushing it and it popping up over the top and out of the surface ever so slightly. Because here's the subduction out here. Interesting. Yeah. Let's start here from the today being the 26th. So look at the 26th. All right. Page 2. Looking for the evenings. A lot of 2s, a lot of 3s. Chiapas, Mexico had a 4.7. That's down there in the armpit of Mexico. Southwestern Siberia. That's kind of interesting. Southwestern Siberia. Lake Baikal, maybe? Yeah, up there, Lake Baikal, looks like. Yeah. So that pressure that came out of Japan looked like it did its number up there. All right. Let's see what USGS has to say. Did it talk about it? No. Anyway, 4.7 as well, and so whatever. Juji, Argentina had a 4.7 at 10. That's the Andes rising up. Kyushu, Japan, a 4.6. 11 hours ago, Kyushu, Japan. And there's the Kyushu, Japan. Yep. All right, so there you go. Helps get use them both. Easter Island. Hey, we haven't. There's the Easter Island. I've been waiting for it. Wow. Easter Island, 4-point earthquake location. All right, so right in here, Easter Island. USGS again does not have it. Did it happen or did it not freaking happen? I guess maybe I'll go 7 days. They don't have it. Partly because they know what we're saying. When something happens down here, immediately I'm going to be looking up into Alaska. Something to happen up in Alaska. So Azerbaijan had a 4.7 9 hours ago or 10 hours ago. Azerbaijan. I mean, that's the first EPR quake that we've had, I can't tell you, a couple of weeks, 2 weeks. Nothing on the EPR, East Pacific Rise. You know that something's not right. Baja, I mean, with a 3.6. Chiapas, all this. Mexico's staying down low at 3.6s and under 4s. Open it. My daughter. 4.2 Chiapas, Mexico. Yeah, Michoacan, Mexico. That's going. Looks like the pressure moves south. Guerrero, Michoacan, and then now Chiapas. So if that's the case, then the chicken leg is moving forward, and then that's why we get a sewer on Baja California. And yeah, there you go, Santa Rosalia. Yeah. So It looks like it went bang, 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 and then bang. Well, that's because it moves that way first. Yeah. I like that, like the deal with you look at it, you drive down the road and you watch the tire spin on another car. It looks like the tire's spinning backwards. That's the same effect. I don't remember what it's called, but when the pressure looks like it was moving south, it actually wasn't. It just broke that way, and it was moving north. And there we have Baja California having pressure put in, and this is the 7 days. Let me go back to the 1 day all mag. Yeah, sewers down here, and USGS doesn't even have it. God, it just what are they doing? And I'm not one to be bitching about USGS, but yeah, Cabo San Lucas. So I'm not one to be bitching about it, but God bless, man. You get an earthquake down there, by a city at least, you should report it. It's right here in La Paz. You know, you put this one down here. This is a 4.7. It's a more significant quake, yes. But this happened in a populated area. Hello? Yeah. I think, Wally, you should tell your friends over at the USGS to get with the program. Stop doing whatever they're doing, or at least get on the board and start doing the work. Yeah, we know there's 200 earthquakes a day, but let the machines print them. You got the damn AI running it thing. Tell them to do it right, Wally. South Sandwich Islands came in 6 hours ago at a 5.3. Here, down here. Straight line, bang. Right here, Argentina, Mexico, New Mexico, all the way through the park, Rocky Mountains. There's a wave right there. That lineament, and I bet you it goes right up to this little volcano up here too. That lineament is real. So hey, there's a new wave moving across the plates, and as we see, we got some out here too. Came out of Fiji about 2 days ago. Here, I think I can put it on there. 7 days. Here they are right here. Fiji is 6.0, and then a bunch of 5s, and they're all deep, 500 and change. And then the whole trench over here. Well, what day was this? This was on the 24th. But on the 21st, this one hit. That hit the 19th, 23rd, and 21st. So these hit first, then this, and yeah, this one hit, and then this. So the pressure moving progressively this direction. And even after these big ones, and then we have this one over here, feeling that same pressure from right to left. And then the latest quake we have is out here in the Flores Sea of 5.1. Still, very, very odd how it's moving around the plate or the plates themselves from right to left, and not in a straight line, just kind of a ever so slight tick. And then they just removed that red line. I mean, it happened how long ago? 9:20. It happened 45 minutes ago. So I guess that's the ticker. The red will turn off after 45 minutes. I guess. No, it's still red. All right. I don't know I don't know what their deal is. Yeah. I wouldn't be a bit surprised if we didn't see this region over here or this region here just go big, like maybe six plus. I'm just saying. Or even up into China. And seeing a lot of split of pressure going around Sulawesi right now with all this mess being pushed that direction and that direction. Right now, it looks like more activity is going to come this way into Sumatra just by watching the pressure move. There's a hurricane right now, no 6. Yeah, Banda is moving. You're saying there's a hurricane right now over there? All right. I have to go to Windy to find it. Yeah. Well, you're right. There is a hurricane right there. Doksuri. Yeah. So that energy that's moving that way may get sucked up by this storm. You're right. Tectonic movements. Yeah. I'm talking about tectonic movements. Yes, sir. As soon as you have to cross the board, you got to give it. The storm and the Banda 5s are, yeah, I think, I don't know if they're this. The storm has been here longer than the 5s in Banda. We did have a really deep one here, didn't we? Not too long ago. We're on the 7. What? I wonder how deep it was. Didn't we have a super deep one? I don't remember where that deep, really deep one. That's 203 there. I think it was a 500 depth, deep. I don't know. It was longer. We had a deep Fiji 5. Yeah. A few days ago. Look at the week on the week to scale. Yeah. That's what I'm saying. That energy definitely moving. So if we take it back on Fiji's 724, that's 2 days ago. Yeah, it didn't take this storm 2 days ago being out here. Monday the 24. It's only a low pressure. Yeah, it was building. Yeah. Radar. Yeah, it was already there. Monday the 24th. And Fiji was on a 26. So I wonder how long it took for it to get to where it's at that spot. I mean, there's been a lot of pressure moving through here. Or, yeah, pressure moving through. The wave of stuff moving across. Push play. I wonder if this storm is from Enzo. Is it Enzo related? Oh, the same liniment? Yeah. Yeah, very well could be. We're watching it as it moves across right now. A legit map. So you need Fauci to tell you it is safe. um, oh, I forgot. I'm going totally to random. Once again, it goes by Taiwan. They will get a 6. That's what I'm thinking. Taiwan's going to get a 6 somewhere up in there. I wonder if we draw some kind of map with lines and call it the antipode crossroads to help people see the tectonic motions. It's very complicated in that area, the tectonic motions, for sure. Look at all it's so jumbled. We've got the rift here, subduction here, both sides of Okinawa. Strike slip, and we got compressional as well up in here because it's squeezing on both sides. Taiwan is it's being squeezed and spun, I think. So it's being pushed down here and pushed up there. So it's being spun. I think some people think Taiwan came out of China, but I'm not sure that it did. I think it somehow came out of here and it's been moving that direction. The same thing I've heard of Japan, that Japan broke off of China up here, and Russia. So I'm not sure that it did. There's no rift to spread it apart, and it is going in a different direction. Pretty much all in the same kind of direction. Now, if you lower the sea levels, well, I don't know. They kind of go to the south-southwest direction. And that all this may be up in here. But they may have come from way up here and come all the way back down. Yeah, maybe. Japan being part of North America continent. Hey! Anyway. So, yeah, Doksuri is right there. I didn't know about the storm yet, but thank you, Wally. You've yeah. International Conference of Neo-Tectonics and Structural Geology coming up. December 23, Amsterdam. You want to go to Amsterdam? Finding early bird registration, you can do it, man. You want to get on there? You want to get it? Abstract, full paper, text submissions. Hey, send your paper up there, Wally. I know you're working on one. Yeah. Just add yourself to a bunch of letters behind your name and see if they buy it. No, he says, I don't want to. What I'm presenting is real. Yeah, it is the neotectonics people. I think they have something maybe akin to who are those people with the had made Washington D.C. And they made the San Francisco and all that. The Masons. They remind me of the Masons a little bit. But then again, I'm stupid. I don't know anything. You can tell me what you think. Anyhow. Hey, there's another storm right behind it. Oh, did you know that one, Wally? There's another one. 91W is right on its tail. They are not random points on a globe. No, but the globe moves. Are they physical points? Are they magnetic points? Or are they something that controls the invisibility of something? Shelling black beans. I don't know. Why you shoot black beans, man? I don't know. Shelling them. Are black beans in a pod? I don't even know. There are magnetic moments. Okay. They're Bigfoot's footprints. Magnetic moment in electromagnetism. The magnetic moment is the magnetic strength and orientation of a magnet or other object that produces a magnetic field. All right. Hold on here. It's moving pretty quick. And let me ask you, Wally, does it turn on and turn off, or is it all the time? Because I'm interested in if a magnetic field moves. Because I think there's either oscillation or movement or I wouldn't say a current, but it's akin to a current, an electrocurrent, akin to a pulse maybe. And it may just be that because we're in time and space, that we see it that way, and rather than it being always movement. So it might be a split in time that we're seeing, or we're time split. I don't know. I think, I'm going after him. I'll see what you're saying here. Let's go eat cake. Strength carry. Yeah. There's a light switch. Yeah. They do move. It is bipolar. Is it bipolar? LOL. Like an aurora. Yeah. But I think the auroras are waves of particles coming through our atmosphere and interacting. They can do with water and more. I studied one of the founders of the Neotectonic group from Australia. He is dead now, but they still are using all of his limit maps to my stuff in Australia. He is one of the main reasons Australia is the world mining power. Waves and frequency, but in general relative to the crust, the field is stable. Do you think it's because the crust is magnetized by the waves and thus have a more centralized particles of being stuck in that place? Time stretch bass nectar. It's bipolar, but we have an equatorial boundary also. The whole world's a magnet. Yeah, I got you there, bud. I think there's multiple magnets myself. The crust particles are just insulating dried waste product from the flow of magma. Agreed. But they have particles in it. Is it a more concentration there than in the magma itself? Or is it just random? Yeah. Look at that, all the way across. Yeah. There's definitely a lot of lightning going on. The crust only shows what the magma was in when it cooled. Mm-hmm. If you study the operates, who operates the ships that do the ocean mapping, you will find they belong to Fugro International. They are the main company in LiDAR and sea mapping plus satellite mapping. Also based in Amsterdam, they started buying up all the ocean mapping smaller companies back in the early 2000s. The magnetic field the Magman was in. And you said dried crust. I know what you meant. You meant cooled magma. Yeah. Interacting with outside in the atmosphere. Yeah. Changing its composition. Si, senor. Anyway. Let's see what else we have. Central Turkey of 4. Guerrero's got a 4. Mexico. Eastern New Guinea got a 4-3. See that pressure moving over there. Oregon, off the coast of Oregon, got a 3.9 5 hours ago. Come on, USGS has got to have that one. Yeah, they do. 23, 24, now 26. Bing, bing, bing. Movement. There's movement here. There's vibrations here. There's vibrations here. Oh, what's happening? Well, make sense of it for us, will you? We already looked at the Vanuatu's. Kepulon Sula in Indonesia 3 hours ago had a 4. Vanuatu had another 5. Nevada had a little 2. Vanuatu had another 5 2.5 hours ago. Alaska Peninsula got a 4.7 at 2 hours ago. Northern Cal 2.6, Northern Cal 2.4. Are they close together? They sure are. Northern Cal. Yeah, it's clear like they're pushing the shit down in the ground and burning it up. They got to. There's a lot of people. They shit a lot. They eat, they shit. 5-1 Flora C, that's what we just looked at. And now we're all normal. We're back. We're up to date. It's up to date. So let's go ahead and look at the COD. Some motion up here, it looks like. Duddy. All right. Push play. Oh, that's some pretty good stuff up there in South Dakota and Nebraska. It's dissipating and it's moving south. Big storm up in I look like Iowa into Iowa. Yeah, into Iowa. Uh-huh. Michigan, coming out of Michigan. Monsoonal moisture coming out of the west. Although it's a little bit lackluster right now. This little pressure down here. Yeah. Might pick up again through Paducah. My boy's right here. Sister's right here. She's catching some rain today. Probably some wind too. My other boy here in Alabama, he looks pretty clear right now. All right, let's go ahead and look to see right now the current storms, if there's any alerts. Just up in here in Canada, and we have one here near Chicago, Special Marine. Gulf of Mexico? Special Marine, Lake Michigan. Down here. Gulf of Mexico. Looks like everything's okay at the moment. No alerts. So, hang tight, everybody. Remember, have a plan. Know what you're going to do in a crisis. And if you don't, there's plenty of people here that can help you with, develop a plan. Make sure you have about 3 months of food. At least comparable amount of water. That's going to take a lot of water to store. Yeah, you can get those plastic buckets. They're big 50-gallon drums. Fill it with water. Keep it out of the sun. Keep it off the cement floor. And hold it. And then make sure you've got a filter and then boil it. And make sure you got stuff to, shelter, food. Plan to protect what's yours. Because when a crisis happens, there's going to be people that want what you have. Big hugs, y'all. Thanks for being here. We went a little long today, but that's all right. I was a little bit late today. And, yeah. Central Turkey and Sulawesi came in with a 5-3 70 minutes ago. And, yeah. Looks like Oklahoma's got some noise. And a bit of noise here in Mammoth. Nothing. We'll keep an eye out for you. Remember, don't get nothing on you. I'm Joe, and I'm out. Talk to you soon. Love you.